So far, we have looked at measure of center, measure of spread, and today we're going to look at, when we piece all that together, um, looking at the visual, just like we did with categorical data when we created a bar graph from our frequency table. So why do visuals matter? We've used numbers to summarize data involving the mean, median, range, IQR, and our 5-number summary, but sometimes it's easier to see similarities and differences than to read them from a table. So today we are going to let the data draw the picture. So I'm going to start off with these two visuals, and I want to kind of ask you, what do you notice, really without talking about what it is, but what's something that you would notice from this other than one's green and one's purple? Well, we can see that the green one is not as big as the purple one, right? In group two, we can also see that group two is longer. It kind of like it's overall longer. Uh, Even the little lines that we see coming out, it's a lot longer. We also see this little dot out to the far left on group two. It looks like they have a line in the middle of each one of these rectangles. One of them is more to the right than the other. So those are some things that I noticed looking at this. How are the two groups similar? Um, well, they look to almost start in the kind of similar place in terms of the far left line. Also, the rectangles seem to almost start kind of similar in a similar area. They're both rectangles. Um, how are they different? We just kind of talked about that. Like the right side is off. The little lines on the right. The purple rectangular is longer. The line in the middle is spread out, or not spread out, but it's moved over more this direction, if that's anything significant. So, what we just looked at were called box plots. And so, to give the picture name, a box plot is a visual representation of the 5-number summary. And some of that stuff that I was talking about is uh, how you interpret like a box plot. And it really is just taking your 5-number summary and making what we just saw. So, for instance, here is a box plot, and you should have noticed, and you can also call this box and whisker, but it starts with a line on the far left that represents the minimum value, which was a part of your 5-number summary. And you draw that line to represent 25% of the data, all the way to your Q1, which is a 5-number summary, your median, your quartile 3, and your max. The box represents the IQR, the interquartile range. Yeah, and then that's it. And then these are broken down between like quartiles. Like, just this is a visual representation of the 5-number summary. So the anatomy of a box plot, the middle shows the middle 50% of the data. The line inside the box, so this line that we saw that was a little bit different in a different spot, that is our median, where our median is. The whiskers extend to the min and max, unless these are outliers. And then you notice on one of those pictures, we saw a point, individual point on the purple one. That's because they had an outlier on that one. So outliers are shown as individual points. So connecting back to yesterday, everything in a box comes from quartiles. It's a 5-number summary and the IQR and outliers. Box plots don't add new information. They organize what we already calculated. So we're going to look at our example heights and use the space provided in our notes and the 5-number summary to create box plots for boys' heights, girls' heights, I guess just boys' heights and girls' heights. And then we're going to compare these two groups. So let me see what I have here. Okay. All right. Sorry, I had to pause my video and create a box plot on here because I did not have one. And if I do it by hand, it's going to be messy. So, anyways, just to kind of show you what that would look like, you're not going to create a box plot for your project, but we need a 5-number summary. That's what the box plot or box and whisker is for. So what we want to first do is we want to try to, if we're comparing two things, we want to create a number line that has at least the minimum and the maximum values of both groups on there to keep them kind of the same. So if I look at the boys' heights and the girls' heights, it's like I have 61 for the minimum boys and 57 for girls. So and then my highest one is 78 on boys. So I'm just going to make a number line that's going to go from 50 to 80. And that way I can label things in the middle. So it's going to look something like this. I actually couldn't figure out, I was trying to do this digitally and not take forever by hand. So I did a online deal. I was not trying to have all the numbers labeled. I was trying to count by 5, but I wanted the little, I didn't want the number 52 and 53 and 54 in there. I just wanted those to be tick marks. But either way, they're there. So just kind of going in order from left to right, these numbers are already minimum to maximum are in order. So I'm going to start off with labeling my minimum at 61 with the little line on there. I don't have any outliers. We already found that out. By the way, your data can be different than mine because you guys have not filled out this survey yet. So I'm using last year's survey so I can do this example. So y'all's numbers may be different and probably are different than mine. But I'm going to go to 61, and then I'm going to draw a line along the number line going all the way to quartile 1 at 68 like this. And then this is where my box begins. So at 68, I'm going to draw a box from 68 to 72. So that's from the Q1 to Q3. That's my IQR area. And then I'm going to label my median at 70. So my median's right there in the middle of that box. And then I'm going to draw another line from the right side of the box all the way to 78 with the line there. And that would be considered my box and whisker, my box plot for this graph. For the girls, I'm going to do the same thing. I'm going to keep the same type of number line. This time I'm going to start off at 57, draw a line to 62. My box will go from 62 to 66 and a half. I'm going to draw a line at 64. It looks like this box is a little bit bigger, meaning my IQR is a little bit bigger. The middle 50% of my data is a little larger. And then I also have going from 66 and a half, going all the way to 70. And then from here, it's kind of hard to see because I want to show these all on the same thing. And so I had to stretch them and stuff. So it's a little bit hard to kind of see the differences like side by side. It might be easier if I stack them on top of each other, but we can see differences. We can see that the IQR, the spread in the middle is bigger on the girls. We can see the maximum and minimum. We can also see the spread from the minimum to the Q1 is shorter for the girls and it's bigger for the boys. From Q3 to the max is larger for the boys and smaller for the girls. And obviously we can see the medians are different. So using box plots to compare groups, we should be able to see the center, talk about the spread, see if there's any outliers, which there wasn't. And this is exactly how statisticians talk about data. So we're going to use our box plots to answer the prompts in your notes. So the prompts in our notes, I don't remember what they say, but I would give you guys, if you're doing this, watching this video, like I'm not going to go over those. Those are something that you can answer based off of that. That I want you to answer, that you need to be able to start thinking that way about data and from looking at a visual. So box plots are a great for comparison, but they don't show us the shape of the data, which is useful for, I don't want to jump ahead of myself, but for that we're going to use what's called a histogram, which looks like a bar graph, but the bars all touch. And histogram is a graph that shows how data values are distributed across intervals. Data is grouped into ranges called bins. And so those bins, the height of each bar shows the frequency, and the bins are a range of data values within that side. So histograms help determine the shape of a distribution. Some common shapes that we can see are symmetric type of shapes, skewed right and skewed left, and this is what those graphs kind of look like. So symmetric is going to look like this bell shape. Skewed right, it looks like the data is getting leveling off or tapering off close to nothing as we go to the right. And on the skewed left, it's the exact opposite. It's like as we go further and further to the left, it looks like it's trailing off towards the left. We should also be able to look at symmetric. We have, and these have box plots underneath them. This is kind of what you'll see. Like notice how the middle, the symmetric one, the box plot, the median's right in the middle. Everything looks symmetric. But when we look at the skewed, the box plot, the median is more to the left and the median's more to the right on the skewed left one. It has a bigger area between Q1 and the median on the skewed left. and a bigger area from the median in Q3 on the skewed right. So this is kind of what the shapes look like. Why is this important? Because it helps us choose the center. We talked about that the other day. If we went and plugged in our data and we saw something that was skewed, and I'm trying to describe the center, I'm not going to want to use the mean here. I'm going to want to use the median to let you know, like, what is that best measure of center there, because that's going to actually describe it, because it's going to ignore these numbers that are really high and really low right here, and give us a better idea of the overall picture, what we're looking at in terms of our distribution. So the shape of the data helps us decide which measure of center is more appropriate. If it's symmetric, the mean is typically used. If it's skewed, the median is more reliable because of outliers. So just to give you an idea, we talked about home prices before, but this is the average home price. This is a really old graph, but this was in 2002, and we can see the average price down here, and the frequency on the y-axis is how many of those homes are sold. This would be considered skew right because it's tapering off. We would use the median here because this $2 million, these couple of $2 million homes and $1.5 million homes, those are not a big idea from the group. I mean, look, there's probably less than 5 of those, even maybe even less than that. Yeah, less than 5 of those for quite a bit. When you have 120 homes that look like they're probably in the 300,000 range, and then almost 100 homes that are in that, like, maybe a little like 350 or 400,000 range, and so on and so forth. So we would use the median here because our graph is skewed. We also talked briefly about batting average. This is a graph of batting averages, and getting our data, we get something that looks like this, and notice it's symmetric. Now here you can use mean or median because they are approximately equal, but typically when we have something like this, we would use, this is a normal distribution, and we talk about the mean over the median, even though it doesn't really matter a whole lot, but it's just common to use the mean when we have something that's symmetric. So that leads us to our, well, actually, I need to show you how to do this real quick. So, hold on, before I get ahead of myself. Okay, so last unit we had, we highlighted our frequency table, and we went up to insert and chart. We're going to do the same thing, and it's probably going to give us a histogram already, and it may give us something that already kind of looks nice, but we want to be able to look at this, and you can see I already have mine down here, but just to kind of remind you how to do that, we're going to highlight our boys data. We're going to go up here to insert. Actually, I'm going to highlight the whole column up here. I'm going to go up to insert, and then I'm going to do chart, and it's probably going to suggest something like this. And there's lots of menus that we can do here. Like I can even go up here and say, I want to, where is that spot? Like my histogram, like it's giving me my bucket size, my bin size. I can change those. Why can't I see my graphs? I don't know where the rest of my graph went. Okay, let me go back and try this again. Insert chart. Like this is actually pretty good, and we should see that this is approximately symmetric. This would be a normal distribution, but I can do things like I can go in here and I can change the, like you can see, like play around with this stuff, but see what happens when you change. We wouldn't want to start, like, we don't want it to look like that. Like we want it to kind of look something like this. That if I had something, if it defaulted to this, I would try to get them closer together. The auto is actually fine here. Maybe I might choose 3, and then it breaks these down in intervals of 3. So this is also approximately symmetric. We're going to go through, and I'm not going to spend time going over this in this video because I already did that in the last one. Oh my gosh, why is things not working? Let me get out of this. But either way, You can click and drag and move these around, but I want y'all to do these for both the boys, the girls, and both. So here's the boys. It should look something similar to this. I kind of made borders around everything, and I'm fixing them right now because I want them to be thicker around that. So we can click and drag. We still have a couple things that we're going to add. So you can go ahead and make those, and then we can just drag those out or drag those back where we want them to be later, because we have some other things that we need to talk about later that we're going to add to this other stuff up here after lower bound. So, but either way, I think when I did the height of the boys and girls combined, the histogram looked kind of weird. So I did change the bin size because I wanted them to kind of be like I'm looking for a certain type of look, right? But the point is that on all of these are all approximately symmetric. Nothing in the real world is going to be perfect. You might even say that this one kind of looks almost left skewed, but no, that would be symmetric because it's kind of similar over here, close over here. Yeah, that's approximately symmetric. We don't see like a big long tail falling off. This one right here might be a little bit shorter, and this big bar would probably be closer over here in this area for that to be skewed left. But this should be approximately normal, and we would say that that's symmetric. So let's go back over here to this. We have a special case bell shape. So if a histography, I'm type these so fast. If a histogram is symmetric and bell shaped, we can model it with a normal distribution. So you're going to open your existing spreadsheet and create histograms. So that's what we just did for boys' heights, girls' heights, and combined. Format each histogram clearly and place right underneath each group's summary statistic. For each histogram, I want you to describe the shape. So those are all bell shaped. Describe which measure of center to use. If they are symmetric and bell shaped, we're going to use the mean. And that's because that is a common measurement when we have symmetric distribution. The big picture takeaway here, different visuals answer different questions. Box plots compare center, spread, and outliers, while histograms reveal shape and guide our choices. Good data analysis use both numbers and visuals. So that leads us into our Delta Math time. Actually, and I'm probably going to, I need to say this in the video, but I need to remember in class, you guys need to be actually starting on this project and starting collecting your data as we're going through. So I'll probably give a day, maybe even tomorrow or something like that, to where y'all can just fill out your form that I need you to fill out that gets it approved by me, and so you can start on your data collection and then do all this stuff, because this will be a lot to do all at once if I just finish all the notes and then have you go.